Welcome to day 13 of calculus. Today we're going to find equations for tangent lines. So in A, it's asking us to find the equation of the tangent line for this function at this x value. So what is the equation of the tangent line to this function at x equals 2? To write the equation of a line, and that's what a tangent line is, we need a point and we need a slope, because we are going to use the formula y minus y1 equals m times x minus x1, which is the point slope form of a line. So let's just take let's do the easy one, which is going to be the point, which has an x value of 2, and then we plug 2 into there and we get 4. So we have a bunch of information right now. We just now need the slope. The slope of a tangent line is equal to the instantaneous rate of change at that x value, the instantaneous rate of change at that x value. And as I've reminded you, I'd like you to keep on writing out the difference quotient, the limit as h goes to 0 of f of a plus h minus f of a all over h. And in this case, our a value is 2. So we know a is 2. So now we just need to plug in and solve this limit. We plug in 2 for a, and now we need to evaluate a little bit. So now we just use the function. The function is x squared, so we're squaring 2 plus h, and that's going to be 4 plus 2h plus 2h plus 4 minus 4. Keep in mind that that's the 4 right there, and then all of this is right there. So now this whole thing is over h, and we still have the limit as h goes to 0. We simplify a little bit, and what's nice is that this 4 cancels with the first one, so it's 4 right there and right there, and now you're left with 4h plus h squared over h. You'll notice I made a mistake and corrected it right there. It is just h squared. So now you can factor out an h from the top, and you're left with 4 plus h over h times h, and the h is canceled. That's the nice thing that happens. Now we end up with the limit as h goes to 0 of 4 plus h. Can we plug in 0 for h? We sure can. So that means the instantaneous rate of change is 4. So now we have a point and a slope. Our point is 2, 4, and our slope is going to be 4. Now we can plug into this equation. We know that x1 is 2. We know that y1 is 4, and our slope is 4. So our equation is going to be y minus 2, because that's y minus 4, excuse me, because that's the y value of the point, equals the slope times x minus 2, the x value at the point. So now we have the equation of the tangent line. This question asks us to do something else, which is graph the function in tangent line on the calculator. So we can just plug in f of x equals x squared into our calculator. This isn't quite in the right form to plug into our calculator. We need to put it in y equals form. So it's going to be y equals 4 plus 4 times x minus 2. And you can plug that into your calculator. Now, when we use our calculator, we start out by entering both functions into our calculator. And Zoom Standard is a really good place to start. We end up with a graph that looks like this. We kind of want to see more of what's going on over there. It does look like it's touching right there. So let's go ahead and change our window. Let's go from, how about negative? Let's go from, I don't know, let's go from 0, x value of 15, and let's go from y min of 0, and let's go to 15. So we're really just looking at the first quadrant here, not the y scale. So let's clear that, keep the scale to 1, but the y max to 15. So when we graph this, it's just the first quadrant. Look at this. Oh, it does touch there. If we want to even make it better, let's x max, let's go x max, I don't know, 6. Graph it. What's it look like? Well, there's x squared in the first quadrant, and there's our tangent line. So does that look like it touches right there? It sure does. So what do we have right here? This is the function f of x equals x squared, and our point right there is 2, 4, and the tangent line equation was y minus 4 is equal to 4 times x minus 2. And visually it does look like it is the tangent line. Excellent. So let's do another one. It's going to be the same exact type of math. We need a point and a slope. So for the point, all we need to do is plug in the x value of 3 into the equation, so it's going to be 2 to the third plus 4. So our point is 3, and that's 8 plus 4 is 12. So we have our point, but now we need to find the slope. And we're going to do that with the difference quotient again, the limit as h goes to 0 of f of a plus h minus f of a all over h. Now it looks like, and might feel like, you're writing that so many times and it's not necessary. Please continue to keep on writing that difference quotient. It's super helpful. Our a value is 3. So if we plug that in, we end up with this. So now you need to actually use the function. So it's 2 to that power, 3 plus h plus 4 minus 2 to the 3 plus 4 all over h. And again, the limit stays out front. Now you just need to be careful with your algebra. And the 4's do cancel. But what you're left with this. The challenge is there's no real way to factor out an h. You can factor out a 2 to the third if you wanted to. You can make it 2 to the third times 2 to the h minus 1 over h. Limit as h goes to 0, but you can't cancel an h. So if there's no algebraic way to cancel the h, you can't plug in 0 because it would make 0 in the denominator. So in this case, you would still have to make a table. And again, you have h and f of h right here. And you have it going to 0. So you need something immediately to the left and right of 0. You end up with the following two values. Fill them in, and then what's in between these two? 5.545. So we think the limit here is 5.545, and that's going to be our slope. So now we plug that into y minus y1 point slope form, m times x minus x1. And what was our point? 312. So it's going to be y minus 12 is equal to 5.545 times x minus 3. And we could do the same thing. We could graph the function. Could graph this function and graph this line and show through a calculator that it does look like it's a tangent line. So let's try that. So remember, you got to plug it in this form. So move the 12 to the other side. And when you plug this into your calculator and graph with zoom standard, looks like it's going to be tangent at x equals 3. But let's zoom out a little bit. So let's change the window. Let's go again let's go to 0. Let's go x max of 20. Let's double it. And we know we don't really care about y being negative, so let's make y max 20 here. So I'm looking at the first quadrant, 0 to 20 and 0 to 20. Does it look like it's tangent? Well, it should zoom out in a second here. Oh, it does. Let's change the window again. Let's make the x max, I don't know, let's make it 5 just to stretch it out a little bit. So there is 2 to the x plus 4 being graphed. And now we should see our tangent line. And is it touching where we hope it does? Well, it does. It touches right there at that single point. So what do we have here? This function right here is 2 to the x plus 4. That function was y equals, written out, 12 plus, what was it? 5.45 times x minus 3. And then what's the tangent point? Well, it's right there. That point, the point of tangency was 3, 12. So does it visually match what we hope it does? It does. So let's do some comparisons here. Which is bigger? F of 1 or f of negative 1, that means the function evaluated at 1. So where is the function at x equals 1? That point right there looks like it is f of 1. So what is the output? Well, it looks like f of 1 is negative 2. What about f of negative 1? F of negative 1 looks like right about there. That looks like it's about 2. So, and you don't have to be too exact, but you definitely know that f of negative 1 is positive. You know that this one's greater than 0. You know this one is less than 0. So therefore, what's bigger? Well, the positive one. So f of negative 1 is greater than f of 1. What about this and this? They look familiar? They are. They are the difference quotients. They are the difference quotients. This is going from 0 to negative 4, 0 to negative 4, and this one's going from 4 to 0. So what you can do is you can draw the lines. You can draw the lines. So on this one, you're going from 0, 0 right here. That's where the function is 0. So what happens when its function is negative 4 right there? What is this slope right here? This slope right here is equal to that, is equal to that. And that looks like it's about 0. But what about this one right here? That's from 0 to 4. 0 to 4, x is 4. Where is x equals 4? X equals 4 right there. So this one right here, that slope, is that positive or negative? Well, this looks like it's less than 0. So which one's bigger? This one's bigger. So we now know that the green one is bigger than the blue one because the blue one is negative and the green one is positive. What does this say right here? f with that little mark, that's f prime of 3. That's the instantaneous rate of change at x equals 3. So where does x equal 3? Well, x equals 3 right about there. So we go down to here. What's the instantaneous rate of change? What's the slope of the tangent line? It's not drawn very well there, and you kind of have to estimate, but it looks like it's either going to be exactly 0 or very close to 0. It really looks like this is going to be equal to 0 or very, very close to 0. What about f prime of -1, the instantaneous rate of change where x is -1? X is -1 right there. So you go to this point, what's the slope of the tangent line here? Well, the slope of the tangent line there really is negative. So which one is bigger? Well, one of them is 0 and one of them is negative. So f prime of 3 has to be greater than f prime of -1 because this one is 0 and this one is negative. What about f prime of 4 and f prime of 5? These are the rates of change at 4 and the rates of change at 5. So the rate of change at 4, where is x equal 4? X equals 4 right there. So we go to this point, we do this tangent line right here. Well, it's pretty positive. What about at 5 right here? Well, if we go to 5, what looks steeper? What looks steeper? This green line or this blue line? Well, it really looks like this whole function is getting steeper, so the tangent lines are getting steeper. So the blue tangent line, the one at 5, is going to be steeper than the one at 4. So it looks like this one is steeper than the green one, so therefore f prime of 5 is going to be greater than f prime of 4. Keep in mind, we don't know exactly what all of these are. We're doing it by relative comparison. Negative is less than 0. 0 is going to be less than anything positive. You can make these